Hello and welcome to Water Quality. In this video, I'm going to continue an example problem that I started in two previous videos. And the example is ferric chloride dissolving into deionized water and the ferric iron ion that's released complexing with hydroxide. So we're describing this reaction both in the complexation form where iron is reacting directly with the hydroxide, and then also in the acid form where the iron is reacting with water and releasing a hydrogen. So that's the acid form of the reaction. And so we've already looked at the first and second acid reactions, and we found values for Ka1 and Ka2 using the beta values off of table 5.1 in Snowy, Inc. and Jenkins or those are the authors, and it's in water quality. And so by extension, it seems like we should be looking for Ka2. Well, let's take a look. So it seems that the next reaction would be for ferric iron to react with 3 hydroxides and form FeOH3. And it does, but when it does that, it forms a solid, and so the possible complex of having an FeOH3 dissolved species that's uncharged is undefined. So there's no value for that in the table because this species is undefined or insignificant. Undefined, insignificant. And so there's no data available on a beta 3 value um, because the FeOH3 solid is going to form. Okay, so let's take a look at where we're at then. If we think about this in terms of alphas, it can be kind of helpful. And so let's go ahead and just sketch out a little diagram of alphas. Now alphas vary from 0 to 1. I'm going to draw a dashed line across the top. This is completely not to scale, but I'll put in a 0.5. So this represents the crossing point where two species are equal. And I'm going to draw in the pKa values. So this is pKa 1, which is equal to 2.16, and this one is pKa 2, which is equal to 4.58. Okay, so at the pKa values, two of the species are equal, so I'm going to draw a dot there at the 1/2, and then I can just kind of sketch this in, just conceptual, schematic for kind of to illustrate the dominant species. So below a pH of 2.16, our first species is going to be dominant, which is the Fe3+, and the alpha that goes with this is alpha naught. Between 2.16 and 4.58, FeOH2+ is going to be dominant, and it has an alpha 1, or it goes with the alpha 1. Okay, and then above pKa2, above a pH of 4.58, the FeOH2+ species is going to be dominant, and this one goes with an alpha 2 value. And just to illustrate that, what I mean by it goes with that is, for example, if I look at the alpha naught, that is the iron 3+ concentration over the CT Fe value. So it's basically telling us the fraction of iron that's present as that species. and then the other two will have similar reactions. So hopefully that clears up why we don't have a Ka2 and helps you understand a little bit better the dominant species in this system.